So, Associative Law of Addition. So, ito yung next properties ng vector addition wherein we have to add 3 or more vectors. Okay, sa commutative kasi meron tayong dalawang vectors lang na kailangan i-add. So, how about if we have to add 3 or more vectors? So, how can we add them together? Okay, so using the associative properties. Now, the sum of the 3 or more vectors, the sum or the resultant, is independent of how individual vectors group together. So for example, may tatlo akong vectors A, B, C. So gusto ko sila i-add. So you can see here. Now, I will add them by grouping first A plus B. So meaning i-add ko muna si A tsaka B, tapos ang resultant ni A plus B, i-add ko ni C, yun yung total resultant niya or the vector sum of the 3 vectors. Okay? So, i-add ko muna si A at B. So, this one first. So, A plus B. So, I have here A. Tapos B. So, i-add ko si A plus B. So, ito yung resultant niya starting from the starting point. Tapos mag-draw ka patungo sa endpoint ni B. So, ito yung A plus B. Now, itong A plus B, after that, i-add natin siya sa C. So, ito si C. Ito yung si C. I-add natin siya ni C. Tapos, si A plus B plus C is actually from the starting point patungo sa endpoint. So, ito. So, ito yung total or the vector sum of the 3 vectors A, B, and C. Now, how about gusto ko unahin si B at C i-add, tapos i-add ko yung result ni B at C to A. So, are the resultant still equal? Yes, because according to associative. Now, let's see. So, iuna ko i-add si B at C. So, I will add first B and C. So, I have B, then I have C. Tapos, resultant ni B and C is starting from the starting point ni tail ni B. Tsaka, mag-draw ako patungo sa endpoint ni head ni C. Okay, so ito yung B plus C. Now, this B plus C, i-add ko naman ito ni A. So, A is going in this direction. So, ito siya. So, B plus C. Tapos, I will add this to A. So, ito yun. And then, after that, to get the resultant of these vectors, so you have to start from the starting point here ni B plus C na tail, tapos i-connect mo siya ni head ni A. So ito yung vector na A plus B plus C or the resultant of the 3 vectors. Now the resultant na ganito is actually equal to the resultant here. Okay, so it doesn't matter kung paano mo i-group together yung vectors mo. So the resultant is actually still the same. Okay? So why do I need to add first the parentheses? Because yun yung rule natin, 'di ba? So you have to simplify first yung ano natin. So basic natin arithmetic. So you have to simplify first yung may parentheses, yung may bracket and so on, 'di ba? So ganun yun. So we have to first add yung merong parentheses. Okay? So another property of a vector is the negative. So example, meron akong A na ito yung direction niya, tapos ito yung magnitude. How can we get the negative of this vector A? So what you're going to do is, that is denoted by negative, tapos yung vector A is, it has the same magnitude as vector A but of opposite direction kasi meron na siyang negative. So, the negative of a vector A will just change the direction but not the magnitude. Okay, so same lang din yung magnitude ng dalawa, ni vector A tsaka ni vector negative A, pero yung direction are in opposite direction sila. So, ito yung negative of a vector A. Now, we can use the concept of a negative of a vector A to, I will incorporate the property of negative of a vector A to the vector subtraction. So, gagamitin natin yung yung natutunan natin sa property of a negative vector. So for example, I have to find the vector difference ni A tsaka ni B. So how can we do this one? So the vector difference is denoted by capital letter P. Okay, so that is the vector difference. So kukunin natin we have to find the vector difference of A and B. So what you're going to do, this negative B is just equal to plus negative, diba? Equal lang, they are equal because of actually the sa inyong basic arithmetic nyo. So how to add negative and ganun. So equal lang man din ito. So we can rewrite the A minus B expression to vector A plus the negative of vector B. Okay? So which means na i-add natin yung vector A sa negative ng vector B, and that's how you can find the difference of A and B. So okay, for example, ito si A tsaka ito si B. Now I want to find their vector difference. So what you're going to do is you have to take the negative of the vector B, okay, then proceed to addition. So as you can see here, proceed to addition. So after getting the negative of a vector B, then proceed to addition. So we have here, uunahin mo natin na pag-draw si A. So I will first draw A, tsaka connect the tail of negative B sa head ni A. So ito yon. So we have this one. Then the vector difference is from the opposite, ito, from the opposite, hindi. From the tail of vector A patungo sa head ni vector B. So ito yung vector difference. Ito yung A minus B, as you can see here. Okay? So that's how you do vector subtraction. So first i-take mo na yung get the negative of a vector B, tapos proceed to addition lang, tapos you can get the vector difference by connecting the starting point to the end point. So ganun lang yung vector subtraction. So next, how about we multiply a scalar to a vector? Okay, so what is the effect of multiplying a scalar quantity to a vector quantity? So for example, so I have here a vector A which is going in that direction, and when multiplied by a positive scalar quantity, say small letter n, so yung product ng NA, so n times the vector A is actually has the same direction as your vector A, but naa siya magnitude equal to n times the vector A. So as you can see here. So meaning that the vector A is n times long as the vector NA. The vector NA, sorry. So the vector n times A is n times long as the vector A kasi minimultiply mo na siya ng scalar quantity na letter n. Okay, so denoted by letter n. So for example, so I have here A, ito. So I will multiply this one by 2. So the effect of multiplying the 2 lang, itong scalar quantity na 2, it will change the magnitude of the vector quantity. So meaning that 2A is twice as long as your original vector A, diba? So they have the same direction lang, but they have different magnitude. Okay? So meaning na twice as long as ni vector A si 2A. Okay? So how about if hindi na positive scalar quantity yung i-multiply natin? So how about if we have to multiply our vector quantity by negative scalar quantity? So for example, i-multiply natin siya ng negative 2. So what will happen? So it will not only change the magnitude of the vector, but it will also change the direction of the vector. So for example, meron akong original vector na ganito. Okay? So next, I will multiply this vector A by -2. So what will happen is, yung magnitude niya is twice as long as ni original vector A, but yung direction niya kasi may negative is opposite to that original vector A. So ganun lang. So that's how you multiply a scalar to a vector quantity. So that's the effect of multiplying a scalar to a vector quantity. So next, let's add or subtract vectors using components. So ito yung mathematical method na pag-a-add o pag-subtract ng vectors. So the graphical will be sa lab, okay? Sa laser focus nyo sa lab yung yung graphical method. Okay, so dito we just have to focus with the mathematical method, okay? So which is the component method. So a component method looks like this one. Okay, so any vector nga nandun sa space natin ay may express natin using components. So we can express the vector using components. So what are these components? So these components are actually projection, meaning projected lang siya na quantity ni vector A dun sa axis mo. For example, my vector A is lying on the xy axis. Okay, so meaning na meron siya sa two-dimensional system. Okay, nandun siya sa two-dimensional system. So the projection of A with respect to y is actually equal to ay. So ito yung value ni A if iproproject natin siya sa y-axis. Now, the projection naman ni vector A towards the x-axis actually your ax. So ito yung value ni A if i-project natin siya sa x-axis. Okay? So therefore, if we have this vector lying in the x and y axis, so as you can see, a vector can always be expressed by its components. So we have A, the vector A, tapos ax, ito yung value ni A projected along x, plus ay, ito yung value ni A projected along y-axis. So ano naman tong I hat tsaka j hat? So I hat and j hat are actually unit vectors. So ito yung mga dimensionless constant ito na nag-specify ng direction ng components mo. For example, your ax is in I hat direction, so meaning nandun siya sa x-axis, and your ay is pointing in the j hat direction, so meaning nandun siya sa y-axis. So we have here ax is the component along x-axis in the I hat direction. So meaning nandun yung I hat direction represents the x-axis if your vector is lying in the x-axis. Now your ay is the component along, hindi to x-axis, ito ay y-axis in the j hat direction. So j hat direction represents the y-axis direction. So these are called unit vectors. I will talk about that later. Okay? So generally, kasi of course we are living in a three-dimensional world, as you can see, so we can extend naman yung vector A expression natin other than x and y to z. So we have another term which represents the projection of your vector along z axis. So represented by k hat direction yung z axis mo. But usually in basic general physics lang, so we will stick lang with the two-dimensional system. Okay? So pero for your information lang, so in three-dimensional, ito yung expression ng vector natin. Okay? So in terms of components. Now, how can we find the x and y component of your vector A? Okay, so how can we do this one? So the last slide, your A is actually oriented at an angle theta. So as you can see here, meron siyang theta na angle. So to find the x and y component, what you're going to do is like this one. So para lang itong SOHCAHTOA, di ba? So SOHCAHTOA lang ito. So can I have a I will get me ito. So ito. So we have here so how to do this one? So if we have the x and y components, so sa last slide we can draw it naman. So we have here tapos ito yung y-axis, tapos ito yung x-axis mo, and then your vector A, so may vector A ka in the oriented at an angle theta. So the projection of your vector A patungo sa x-axis mo here, so ito yung AX mo, so this one yung AX mo ganito. Then your AY is a projection of your A patungo ni y-axis. So this is your AY. Now sa SOHCAHTOA is ganito. So to find the x and y component, you need to use the SOHCAHTOA method. So sa trigonometry nyo, so we have the SO. The SO means sine is opposite over hypotenuse. So for example, the sine of theta, so the theta here is si theta na oriented ni A is actually equal to, what is the opposite side ni theta? So ito, so excuse me, ito yung opposite side, pero this opposite side is actually equal ni AY, diba? So equal lang ito ni AY, as you can see here. So we have opposite AY, tapos sa hypotenuse is yung angle opposite ni ni 90 degrees na angle. So the right angle. So we have here the A. So the vector A, the magnitude of the vector A lang. Okay? So we have here your AY, then your Y component is actually equal to the magnitude of vector A times sine of theta. Ganun lang. So how about your cosine theta? So okay, so that is CAHTOA, so meaning cosine is equal to adjacent over hypotenuse. So we have cosine theta is equal to, what is the adjacent? So the adjacent is actually the AX. So we have AX here divided by the hypotenuse is again the magnitude of your vector A. So therefore, your cosine theta is equal to, no. So can I erase this one? So your AX or the X component is actually equal to the magnitude of A cosine of theta. So ganun niya lang. So that's how you do the components of vectors. So ganun lang. So as you can see here, ito yung AX mo, tapos ito yung AY nyo. Now, remember, if we have to find the x and y component, these two equations or two formula that we had are not always true. Kasi dependent sa orientation yung angle theta mo. So depende kasi yung AX tsaka yung AY sa orientation of the angle theta, 'di ba? So you just have to remember SOHCAHTOA. Okay? So if you don't want to remember SOHCAHTOA and you have to stick with the formula given by AX and AY. So what you're going to do is you need to find the conventional measurement sa angle mo. So how to do that? So if I say conventional, meaning that your angle, the measurement of your angle starts always from the positive x-axis. So meaning kung nag-start siya sa positive x-axis, meaning your angle is always positive. Diba? So rotating counterclockwise yun. But if mag-rotate siya na clockwise, then your angle is negative. So ganun lang. So for example, so I will give you an example. So how can we do this one? So for example, if kanang your angle, I mean your AX and AY cannot be hindi ma-use yung formula na ito at ito, so hindi siya ma-use. So how to do this one? So for example, so you just have to remember SOHCAHTOA. So I have here your x at saka your y axis. So mag-stick lang tayo sa 2 dimension. Tapos your angle is oriented like this one. So this is your vector, say A. Tapos yung angle mo is ganito. So you cannot use directly AX and AY sa formula na sinasabi ko na ganito. Because this angle is actually not a conventional. Okay? So conventional measurement ng angle mo. Kasi mag-start always ang conventional measurement of angle from the positive axis. Okay? So dito siya mag-start. Now here, so if you will just stick with theta here, so what you're going to do, you have to remember SOHCAHTOA. Okay? So I have to project my A patungo ni y-axis. So the projection of my A to y-axis is this one. So ito yung AY ko. And the projection of my angle ay your vector A patungo ni X is ito. So ito yung AX ko. So what you're going to do? So ito yung AX ko. So as you can see here, yung SOHCAHTOA, so sine theta is actually equal to opposite over hypotenuse, diba? So anong opposite side ng theta mo if you are stick with this theta? So yung opposite side is yung AX mo, diba? So because this one is your AX, so equal ang side nito ni AX, diba? So this is actually your AX din naman. So therefore, we have AX over the hypotenuse. So meaning, this formula that I gave you is not always true. So it depends always on the angle. Okay, as you can see here, sin theta yung X mo. So therefore, if sin theta yung X mo, then your Y must be the cosine theta. Okay? So ganyan lang. So if you want to stick with the SOHCAHTOA, then you can do it. But if you want to use the conventional measurement para hindi na kayo remember ng SOHCAHTOA nyo, so you just have to stick with this formula. So ito lang yung formula na i-memorize nyo, tapos i-internalize nyo na formula. Ganito lang. So your AY, the Y component must be represented by your sin theta. Your AX must be represented always by your cosine theta. So what you're going to do is you have to, just like what I said, na conventional measurement. So how to do the conventional measurement? So we can shift your theta here. So I will start from the positive x-axis, tapos mag-rotate ako ng counterclockwise. So that is equal to 90 degrees. Okay, diba? So therefore, itong 90 degrees mo, i-add mo sa theta mo. So therefore, the angle na orient na si A mo, yung vector A, kung saan nag-orient na si vector A, your theta of your vector A is now equal to 90 degrees plus the original na angle ni vector A. Diba? So by using this one, you can actually use na this formula. So there's no need for you to do the SOHCAHTOA all over again. Okay? So you can use this one. Oh, this is your vector A, your sine theta A. So the theta A here is actually the shifted na angle. So meaning I will shift this one, I will shift the angle theta, yung original orientation ng A mo, by adding 90 degrees. So ganun lang. Okay? So that's how you do that one, the conventional. Okay? So ito. So this is actually the conventional way of measuring an angle. So ito yung conventional way starting from the positive x-axis patungo kung saan nag-point si vector A. Okay? So example naman, if your vector A is, for example, okay, so I will insert a page. Okay, insert ako ng page, blank page. Okay, so ito. So I have here draw. So this is your y and this is your x. So this is your Cartesian coordinate system. Now your angle must be, if your angle is rotated counterclockwise, so ganito, counterclockwise ito. So counterclockwise. So this angle is positive. Okay, so Control Z. This angle is positive. But if your angle is rotated clockwise from the positive x-axis patungo say here, ito yung angle theta mo, then this angle is negative. So ganun lang. Ganun lang yung conventional measurement ng angle nyo. If counterclockwise siya from positive x-axis, then positive yung angle mo. If clockwise from positive x-axis, then negative yung angle nyo. Okay? So then, next. Okay, so ito. So now, since your angle is since your components are dependent on theta, then the sign of your components is also dependent on your angle. So meaning kung saan naka-oriented saan yung orientation ng angle nyo. Okay, for example, if your angle is oriented sa quadrant 1, so na-locate siya sa quadrant 1, then you can sure that your x and y component are both positive. Diba? So if your angle is from 0 to 90 degrees. Okay, so between lang ng 0 at 90 degrees. But if your angle is in the second quadrant, okay, so you already know quadrants, diba? So sa Cartesian coordinate naman nato is, nag-divide naman tayo ng 4 quadrants. So this is your quadrant 1, 2, 3, at saka 4. Okay, so if quadrant 1 siya, so your x and y are both positive, so dito. But if nasa quadrant 2 siya, then your x is negative but your y is positive. So in quadrant 2, your angle is between 90 degrees and 180 degrees. But if quadrant 3 naman siya, your x and y are both negative. So that is if the conventional measurement sa angle is from 180 degrees to 270 degrees. So between ng 180 at ni 270. But if your vector is oriented in quadrant 4, meaning that the angle, the conventional angle is between 270 to 360, then therefore your x component is positive while your y component is now negative. Okay? So, mali to. So, sa ito mali yun. So, this must be negative here and this must be positive. While this must be positive, this must be negative. So, sorry about that. Okay, so for example, if the angle of a vector A is 60 degrees, meaning this 60 degrees is actually the conventional, okay, then both of its components are positive because na ang 60 degrees is between 0 and 90, then both x and y component are positive. But how about if 120 naman? So assuming that this 120 degrees is conventional, so meaning nag-start siya from positive x-axis. So if 120 yung vector ay yung angle na orientation ng angle ng vector A mo, then x component is positive. I know the x component must be negative, but the y component must be positive. So wrong. This is wrong again. So I'm so sorry about that. Because nandito siya sa quadrant 2, your x must be positive. I mean negative, but your y component must be positive. So this is wrong. Okay, sorry about that. Kasi your angle is between 90 to 180. So this is quadrant 2. So therefore your x must be negative and your y component must be positive. Okay, so how about if you are tasked to find the magnitude na and direction of a vector using components? So we are done finding how to find the components of a vector. Okay, but how about if we are tasked to find the magnitude and direction of a vector using components? So ito lang yung formula na i-base nyo, okay? So if you are calculating the magnitude of a certain vector with components, so ito lang. Just have to take the square root of ax squared plus ay squared. So, i-squared mo lang yung components nyo, then add them, then take the square root, and that is your magnitude. Again, magnitude is always a positive number. So, walang negative na magnitude because it is actually the length of your vector quantity. So, always na siya positive number. Now, how about your direction? So, the theta actually, as for your information, your theta is actually the representation of direction of your vector. So your theta represents the direction of your vector. So that's why I put here the theta. So the orientation of your angle of your vector A. So theta is actually the inverse tan of AY over AX. So that's how you do the in finding the magnitude and direction of a vector. Okay? So again, sa magnitude wala tayong problema kasi ganito lang, okay? But sa theta, there might be a little problem there because the inverse tangent in your calculator does not, although it is correct mathematically, pero in representing the vector is hindi siya correct physically. Okay? So what do I mean by that? So what I mean is that you have to draw first your vector orientation. Okay? So i-draw mo na yung vector nyo, tapos kung makita nyo na makita nyo na your theta actually represents the orientation of your vector na nakita mo sa calculator mo, then that is correct. Okay? However, if your theta in your calculator na nakuha mo sa calculator mo does not correspond or does not represent the orientation of your vector A na na-draw mo, then therefore, you have to shift naman the angle. So I will just talk about it later on how to what are the cases na you have to shift your theta. Okay? So again, so last slide, so last slide, so we are talking about unit vectors. So what are unit vectors? So unit vectors are actually, again, dimensionless vector. So they are only used to specify the direction, wherein your I hat represents the direction along x-axis, your j hat represents the direction along y-axis, and your k hat represents the direction along z-axis. Okay? So from the word unit kasi siya, so the magnitude of that unit vector is always equal to 1. So always. So meaning the magnitude of I hat, the magnitude of j hat, and the magnitude of k hat is always equal to 1. So ito lang. Ganyan lang. So that are the properties of a unit vectors. So we are done with getting to know the components of a vector. Now, how can we add vectors using components na? How can we subtract them? So what you're going to do is like this one. So, for example, sa graphical method mo, so in components kasi, we have to find the y, x, and y components. So that is why you have to make sure nga meron kayong definite na axis kung saan kayo magdo-draw. Okay? For example, I have a y and x axis here, and I put the tail of your vector A sa origin ng x and y axis mo. So we have here. Then connect this one to vector B. So ito, so I already said about that sa last slide. So you have to connect the head to the tail of vector B. So that is A plus B. Tapos yung resultant is from the origin patungo sa endpoint. So the head of vector B, the resultant is how to get the resultant. So what you're going to do is to find the components of your resultant. You just have to add the x components of A and B for the x component, the resultant, and for the y of component ng resultant, you just have to add the y component of A and the y component of B. So ito lang, ax plus bx tapos ay plus by. And to find the magnitude, so again same lang din, you have to take the square root of the sum of the squares of the components of your resultant, rx and ry, and taking the direction which is your theta, so na inverse tangent, we have ry over rx. Now remember, I usually add ax plus bx for x component of r because they have the same unit vector. So you have to take note, you have to add components according to unit vectors. If they have the same unit vectors, then add them. But if they don't, then you cannot add them. So ganun lang yung pag-add ng unit vectors. So same unit vectors, add. So very important note in using the mathematical method of adding or subtracting vectors. So the first note, vector addition is different from scalar addition. Okay, because scalar addition follows the ordinary arithmetic, mga basic arithmetic nyo niya. 1 apple plus 2 apples is 3 apples, ganun. Ay, 1 apple plus 2 apples, yeah, ganun lang. So for example, I have here 1 degree Celsius temperature at i-add ko siya sa 3 degrees Celsius na temperature, then add 1 and 3, we have 4 degrees Celsius. So ganun lang, as long as they have the same unit, so ma-add mo siya directly. Okay, so but for vector addition, you have to take note about different properties of vector addition. I mean, when adding vectors, so ito yung mga commutative, negative vector A, multiplying scalar, merong associative. So yeah, meron din tayong component method. So different talaga yung a vector operation sa scalar operation. Now the second note is your ax or the x component of your vector is not always associated with cosine function. Okay? Same also with the y component of any vector. Hindi siya always associated with the sine angle nga function. So depende lang din sa angle orientation. So that's why I draw it to you, so para I will give you the example. So, na-give ko na yung example na ganito. So, where your x component is not always associated with cosine and your y component is not always associated with your sine. So, true lang ito, meaning your x component is associated lang ito with cosine and your y component is always associated with sine function if we measure the angle from the positive x-axis. Okay? So, if your angle was measured from the positive x-axis, then your x component is your cosine, your y component is your sine. But if hindi, then you have to think about your SOHCAHTOA na rules. Okay? So, think about SOHCAHTOA or measure the angle from the positive x-axis. So, it depends on you. We have the same answer. Okay? So, there are many ways to kill a chicken. So, that's what I meant. Now, third note, reminder in using the component method is always use a deg mode in your calculator. So, deg is degree mode in your calculator for the inverse tangent function. Kasi if meron kayong rad, so, may possibility that your answer is wrong. Okay, so dapat you have to take note na your calculator that you are using today must be in degree mode para makuha niya yung degree na version ng angle mo. Kasi meron tayong rad, so which is the rad mode or radian mode ng angle nyo. Okay? So the inverse tan will always give you from negative 90 degrees to positive 90 degrees. So that is why it is very important to draw your vector. Kasi if your vector is oriented originally sa 120 degrees, okay? So sa pag-draw mo is nakita mo na oriented pala siya sa 120 degrees. Pero nakita mo sa sa calculator nyo, sa pagkuha nyo ng inverse tangent function is nakita kayo ng bakit ito ganito? Bakit bakit 60 degrees ito? Bakit negative 60 degrees ito? Bakit hindi 120? So that is why it is very important to take note of that. So that's why you have to draw the vectors first. So I will give you an example, okay? So para hindi kayo malito. So for example, you have here a vector. Okay, so you anticipated that your vector is pointing in a 120 degrees na orientation sa angle. But your theta and your calculator is, ang na-measure niya or na-calculate niya is negative 60 degrees. So although this is correct in your calculator, pero sa vector mo is hindi siya correct. So that is why please do not answer this one. Answer based on your anticipation. Your pag-draw sa vector mo. So how can I do this one? So negative 60 degrees is actually equal to 120 degrees. So for example, the negative 60 degrees is actually given by that. So this is the negative 60 degrees, diba? So equal lang sila. Kaso they're equal. As you can see, they're forming a straight line. They're actually equal. Kaso yung yung orientation ng vector nyo is actually in 120 degrees. So dapat you have to answer 120 degrees, not negative 60 degrees. Kasi yan yung true na orientation ng vector A nyo or your vector nyo. So, hindi negative 60 degrees. Although mathematically they are correct, but in physics or as you can see sa drawing nyo, hindi siya correct. Okay? So, that's an example. Okay? Then we are done. So, sample problems will be given Yeah.